Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 12, Midpoint Theorem, Exercise B, which is easier than Exercise A. Also, for enrolling for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. So in the B exercise, we have another theorem, equal intercept theorem. So make sure you practice this as well along with the solved examples. Now cancel 1.2, 1.3 and 1.4, which is of the same type. So you just have to do 1.1 for homework. Also mark the following sums as IMP: 4, 6 and 15. Let's start with the second sum. The figure is given. It's also mentioned that PR is parallel to BS, as also that twice of AD is equal to AB, and Q is the midpoint of DR. So we have to prove that AQ is parallel to BS. Our strategy will be to prove AQ parallel to PR, and PR is parallel to BS, so that means AQ will be parallel to BS. So first of all, we assume AD to be X, and they have mentioned that AB is twice of AD, so AB will be 2x. They have also mentioned that P is the midpoint of AB. It's mentioned in the question. That means AB is equal to PB is equal to X each. So we've got X, X and X. This DB has been trisected now, even though it doesn't look like that. On the other hand, here Q is the midpoint of DR. That means DQ is equal to QR. So in triangle DPR, we just proved that A is the midpoint of DP because X and X, and Q is the midpoint of DR, already given. That means AQ is parallel to PR, which is what we set out to do, and PR is parallel to BS, hence AQ is parallel to BS. Now Roman number 2, we have to prove that DS is thrice of RS. That means we have to prove that even DS is trisected. Now we already know that Q is the midpoint of DR, so DQ is equal to QR. Also, since AQ is parallel to PR is parallel to BS, and we have 3 parallel lines and we have 2 transversals, that is just lines cutting the parallel lines, AB and QS are transversal. So if we have 3 parallel lines, then AP upon PB will be equal to QR upon RS. That is, whatever is the ratio here will be here as well. Interestingly, AP upon PB is 1 upon 1. They are equal in fact. That means QR and RS will also be equal. This means DQ is equal to QR is equal to RS. That means DS is thrice of RS. Next, in the fourth sum, there is a triangle ABC, and the medians BP and CQ are produced up to points M and N respectively, and some conditions are given. Prove that M, A and N are collinear. Now try to draw the diagram on your own before I show the diagram. See if you get it. This is very similar to a solved example as well. The diagram looks like this. Now in my diagram it is clear that NAM is a straight line, but actually we have to prove it. What is given in this diagram is that Q is the midpoint of AB as well as of CN. Similarly, P is a midpoint of AC as well as BM. That is what is given. So, in triangle CNA, Q and P are respective midpoints. That means QP is parallel to NA. Similarly, QP is parallel to AM, and it's half of AM and half of AN respectively. That means NA and AM are parallel to each other. But if two lines are parallel and they are passing through the same point, which is A in this case, it means that they are one and the same line. That means NAM is a single line, and that means NAM are collinear. So after this we should write one more statement that N, A, M are collinear, because that was the question. We should always write the final answer the way they have asked us to. And for Roman number 2, well, QP is half of AN and QP is half of AM. That means AN and AM are equal. That means A is the midpoint of NM. Next, sixth sum. There's a parallelogram. E and F are midpoints. We have to prove two triangles congruent in Roman number 1. So draw the diagram first. Try it on your own. Was it like this? I have to prove triangle FHC and BEH. These two triangles congruent. First of all, since ABCD is a parallelogram, that means DC will be equal to AB, opposite sides of a parallelogram, and they are also parallel to each other. So half of DC will be equal to half of AB. That means FC will be equal to EB, because F and E are the respective midpoints. So for these two triangles, I got one thing, side equal to side. Also, I can say angle equal to angle, alternate angles, since this is parallel to this. I need one more thing. We can go for vertically opposite, or we can go for another alternate angles. So these two triangles are congruent by SAA or ASA test of congruency. So proved. Now for Roman number 2, we have to prove that this is a parallelogram. So first of all, since these two triangles are congruent, that means EH is equal to HC, CPCT. So H is the midpoint of EC. So in triangle CDE, H is a midpoint and F is a midpoint. So by midpoint theorem, FH is parallel to GE or DE, whatever. Similarly, we can prove that GF is parallel to EH. So we just have read similarly, and since the opposite sides are parallel, so it is a parallelogram. Next, the eighth sum. In triangle ABC, M is the midpoint of AB, N is the midpoint of AC. Come on, draw the diagram. And we have to prove that MN bisects AD. That means I just have to prove that E is the midpoint of AD. But they said use intercept theorem. First of all, M is a midpoint and N is a midpoint as given in the question. So MN is parallel to BC. And of course, even half of BC, but that is not relevant here. Now I could have gone on to say that in triangle ABD, M is a midpoint and ME is parallel to BD. So by converse of midpoint theorem, E is also the midpoint, but no. They said use intercept theorem. So for that I need three parallel lines. So the construction is to draw a line PQ passing through point A such that it is parallel to BD. And now that we have already proved MN is parallel to BD, that means all three lines are parallel. If all three lines are parallel, that means this upon this will be equal to this upon this. You know, the ratios cut, the intercepts formed will be the same ratio. That's the intercept theorem. And incidentally, here this upon this is 1 upon 1. That means this upon this is also 1 upon 1. That means AE is equal to ED. By the way, the intercept theorem says that if this was 2 and if this was 1, 2 centimeters and 1 centimeters, let's say, and if this is let's say 6 centimeters, you know how much would this be? It would be 3 centimeters, because the ratio will be the same between 3 parallel lines. That's the intercept theorem. But in this sum, since the ratio is 1:1, this is also 1:1, that means E is the midpoint of AD. Next, the 10th sum. In a triangle, A, B, C, D and E are midpoints, and through E a straight line is parallel to AB to meet at F. Prove this is a parallelogram. Also some values have been given which you have to use to find the perimeter of the parallelogram. Come on, draw the diagram on your own. You must do that on your own, because the training is very important to be able to draw diagrams of geometry on your own, because if you are not able to draw correct diagrams, how will you proceed ahead in exams? So the 10th sum, this is the diagram. Notice this is 16, this is 18, this is 12. Now I have to prove this as a parallelogram. We've done such sums. This is a midpoint as given, this is also a midpoint as given, so this is parallel to this as well as half of this midpoint theorem. And this is already parallel to this, so this becomes a parallelogram. Done. Now perimeter of a parallelogram is nothing but side plus side plus side plus side, or you can say 2 times one side plus the other side. I can't call it length and breadth, even though you do, it's okay. So how much is DB? Clearly it's 8, half of 16. And how much is BF? Definitely 9, half of BC. But is F the midpoint? How can I be sure? Okay, we'll have to mention that then, that in triangle CAB, E is the midpoint and EF is parallel to AB. Hence F is also the midpoint by midpoint theorem. We can't just assume it. We have to show each and every step. What is the use of this 12 then? Nothing. It's of no use. It's there to fool you. So 8 plus 8, opposite sides are equal, right? And 9 plus 9, the total answer is 34 centimeters. That's the perimeter of this parallelogram. Now the 12th sum, the diagram is given in the 12th sum. So here we have to prove BP is equal to twice of AD. I'm wondering that if AD is equal to BC, then if I have to prove BP twice of AD, it means I have to prove BP twice of BC. That means I have to prove C as a midpoint. Okay, so let's start with that. What is given in the question? First of all, always mark those things in the diagram. E is a midpoint is given, and this is parallel to this is given. So whatever is given, if you mark it, it becomes easy for you to visualize what to do next. So what to do next? Yep. In triangle BAP, E is a midpoint and BC is parallel to AP. So by converse of midpoint theorem, C is a midpoint. That means BP is twice of BC. But BC is equal to AD, opposite sides of a parallelogram. That means BP is twice of AD. Done. That is Roman number 1. In Roman number 2, we have to prove that O is a midpoint of DC. No, O is a midpoint of AP. Sorry, that's what you have to prove. O is a midpoint of AP. How do we go about doing that? Okay, in triangle APB, C is a midpoint and this is parallel to the base. That means O will be the midpoint by converse of midpoint theorem. So this exercise is totally about midpoint theorem and converse of midpoint theorem. Very few sums on intercept theorem. And finally, the 15th sum. This chapter is turning out to be one of the easiest in geometry, isn't it? Adjacent sides of a parallelogram, finally a challenging sum, are equal and one of the diagonals is also equal to any one of the sides of this parallelogram, and show that the diagonals are in the ratio root 3 ratio 1. So the diagram is like this. What they are saying is that one side, let's say AB, is equal to its adjacent side, let's say AD. Now we know that opposite sides are equal. The moment they said that adjacent side is equal, that means all four sides become equal. So it becomes a rhombus, by the way. Not only that, they are saying that one of the diagonals, let's say BD, is also equal to the side. That means AB is equal to AD is equal to DB. That means ADB is a equilateral triangle. In a rhombus, the diagonals are not equal. No. However, the diagonals are perpendicular bisectors of each other. That is why it was important for us to prove first that it is a rhombus. Here the given is not given, so you have to mention the given properly in the to prove as well. And then the proof starts. So first we prove it to be a rhombus. Then we use this property that diagonals are perpendicular bisectors of each other. And since they are perpendicular, we can now use Pythagoras theorem. In triangle AOB, AB squared is equal to AO squared plus OB squared. Now we will substitute these terms in terms of what is asked. In to prove, I need AC and BD. So please convert all of them in terms of AC and BD. AB squared. That is nothing to do with AC, but I can write that AB squared as DB squared because they are equal. See here, AB is equal to DB. AO is half of AC, so I will write that. And OB is half of BD, so write that. And now this is simple algebra. To solve them further, squaring all the sides, taking the like terms together, taking out the LCM, 4 and 4 denominator disappears, take the square root and we get the final ratio. Make sure you don't leave the answer as a fraction but as a ratio.